Hi again. Okay, quick recap. The vertebral column surrounds and protects the spinal cord. Remember, the spinal cord is the second structure of two in the central nervous system. It is continuous with the medulla oblongata portion of the brainstem, which is where all spinal cord impulses travel through. There is a foramen in the occipital bone of the skull called the foramen magnum, through which the spinal cord passes so it can remain continuous with the brainstem. The foramen magnum is the largest foramen in the entire body. The spinal cord is a thick structure measuring about 17 inches in length down the center of the vertebral column that begins to divide between the first and second lumbar vertebrae. At this point, it divides into many spinal nerves and it resembles the look of a horse's tail. Therefore, it's called cauda equina. Cauda meaning tail and equina meaning horse. The spinal cord is a bundle of nerve cells and fibers and the main highway for all impulses from our body to our brain. It receives messages from the body, sends them to the brain for interpretation, and then receives the brain's response and sends it back out to the body. Cool, huh? If a spinal injury occurs, there is potential for it to be an incomplete injury, but there's also potential for it to be completely severed, which is very bad. Earlier in our lecture, we discussed the structural differences between the central nervous system and the peripheral nervous system. At that time, we listed the cranial nerves as part of the peripheral nervous system, which is mostly true. But I have to shoot it to you straight. Cranial nerves 1 and 2 are technically part of the central nervous system, and nerves 3 through 12 are in the peripheral nervous system. But please don't get hung up on that. There is so much more for you to learn right now. What you should pay attention to are what all 12 nerves actually do. For each cranial nerve, there is a right and left branch, so that the right and left sides of our body have the same capabilities. Cranial nerve number 1 is the olfactory nerve, and it's a sensory nerve that allows us to smell. The second cranial nerve is the optic nerve, and it too is a sensory nerve that allows us to see. Cranial nerves 3, 4, and 6 are the oculomotor, trochlear, and abducens nerves. These three nerves are all motor nerves that allow our eye muscles to function. We just learned about cranial nerve number 5, the trigeminal nerve, and it's a mixed nerve. That means it has both sensory and motor capabilities. It gives our teeth, eyes, facial skin, and tongue sensation, but it's also a motor nerve for our jaw muscles to facilitate chewing. Cranial nerve number 7 is the facial nerve. It's also a mixed nerve. Its job is to give us the sense of taste and to control our facial muscles to allow us to have facial expressions. Remember when we talked about parotid gland procedures in ENT and how we had to be aware of the facial nerve so that the patient wouldn't be rendered unable to show facial expressions? Of course you do. Your brains are steel traps. Your cranial nerve number 8 should be familiar because we studied it in ENT as well. It is a sensory nerve that allows us to hear. Study both names for cranial nerve number 8, vestibular cochlear and acoustic, because the two names are used interchangeably in our field. Cranial nerve number 9 is the glossopharyngeal nerve, another mixed nerve that gives our throat sensation. So whenever you get a sore throat, you probably can curse cranial nerve number 9 until you sip something soothing like warm liquid. And then all of a sudden we love cranial nerve number 9 because its motor capabilities allow us to swallow. Cranial nerve number 9 really toys with our emotions. Moving on. Cranial nerve 10 is the vagus nerve. Oh, how we adore cranial nerve number 10. The vagus nerve is the longest nerve of all 12 cranial nerves. It originates the medulla oblongata and traverses our neck, thoracic, and abdominal cavity, giving sensation to our internal organs but also motor function so that they actually work. Got a stomach ache? Think cranial nerve number 10. Did you enjoy a meal and successfully digest said meal? Think number 10. Did you just take a breath of fresh air? Think number 10. See? Cranial nerve 10 is good to us. Except for when it isn't. But we already studied that in general when we talked about vagotomies. Remember? Cranial nerve 11 is the accessory nerve, and some people throw in the term spinal in front of it as well. So sometimes people call it accessory, and sometimes it'll be called spinal accessory. So study both of those names. It's a motor nerve that innervates our neck and back muscles. The final cranial nerve, number 12, is the hypoglossal nerve. It's a motor nerve that controls our tongue muscle, allowing us to talk. When was the last time you held your tongue with your fingers and tried to talk? I don't know, 4th grade? Do it again sometime, and then thank your 12th cranial nerve for all it does for you. Finally, there's a popular mnemonic device that helps many healthcare professionals remember all 12 of these nerves. And it goes, on old Olympus, towering tops, a Finn and German viewed some hops. In this version, they are calling cranial nerve 8 acoustic and cranial nerve 11 spinal accessory nerve. It's catchy, it rhymes, hooray. So we've covered the brain, the cranial nerves, the spinal cord. Onward to the spinal nerves. There are 31 pairs of spinal nerves that correspond to the spinal segments from which they originate. They can take the same names as the vertebral levels. So, vertebral level C1 has a spinal nerve C1, which would be great if the body just sent the nerves somewhere and that was the end of the story. But we know all too well the body is way more complex than that. And so when the spinal nerves branch, sometimes they combine with one another and they make new nerves. I don't expect you to get that detailed. That's what neurosurgeons are for. But you're going to see the product of spinal nerves combining when we get to the peripheral nervous system slide. So be ready. Every spinal nerve has 2 roots. There is a ventral root, and on this picture, notice how it has red lines in it. You can know it's the ventral root because if you laid that picture onto the picture with the vertebral body, you would see how the vertebral body is on the side closest to the ventral root. Remember, ventral means toward the front of us, and the body of every vertebra is towards our abdomen side. The dorsal back root, shown with 2 blue lines traveling through it, will be nearer to the spinous process. You know, the bumpy spine that we feel on our backs. Ventral roots are responsible for motor function. Dorsal roots are responsible for sensory function. So, just for kicks, I looked up spinal nerve or nerves responsible for our bladder. S2 and S3, which branch from the sacrum, innervate the bladder. So, the dorsal roots of S2 and S3 will allow us to feel the sensation to need to urinate, and the ventral roots will allow the bladder sphincter muscles to relax when we begin urinating. This is a good reason why back surgery can be deemed an emergency when, say for example, the S2, S3 nerve roots are impinged and the patient is experiencing urinary incontinence because they cannot control their bladder function. So these 2 nerve roots branching off the spinal cord in 31 different places will come together briefly to communicate to one another, and then they branch apart again. And that is called the ventral and dorsal rami. They then go off to their place in the body and do their thing. And because I am a self-described dork, I can just imagine the conversation the neurons are having when they meet up for that 1 second and then they go about their day. Hey, ventral nerve neuron, what's up? Yeah, I'm just about to head out to the bladder and make her need to pee. Yeah, I know it's the middle of a movie. What? It's not a good time? Well, shoot, I've already left the spinal cord. Can't really turn around now, can I? She's just gonna have to deal with it. I'm impressed by how much you don't want to interrupt the movie for her. I hope some of your friends are available to help her make her hold it. Well, see you later. I know, I warned you, I'm a dork. Welcome to the inner workings of my cerebrum. You've made it to the final anatomy slide, the peripheral nervous system. I alluded to the fact the spinal nerves leave the spinal cord and sometimes join forces with neighboring spinal nerves to form specific peripheral nerves. Well, here's a nifty picture of those joined nerve forces. Nerves like the sciatic, the ulnar, the radial nerves. They are all a byproduct of the spinal nerves branching off the spinal cord.